All right, on today's episode of Python Papi, we're back inside our cryptocurrency project. And we're starting this one early because we were supposed to start it a few days ago or probably yesterday, but we got tied up with things, so we're going to get it early and get to it. So let's get in and get it pulled up so we can start. So if you recall, the last thing we looked at was the opening when we actually showed you the introduction and how we're going to be looking at. Let me show you that here. 1 second. So this was the blueprint, how everything was going to be set up. And this is just the shell of what we're going to do to start setting the actual blockchain up. And then on the next slide is going to be not the slide, but the next page we're going to go over is the explanation of what we're looking at there. So you can see here, this is that slide here. We go to the top so we can see. So now let me explain what we're looking at or what's taking place here. Building the first block class. A blockchain comprises of several blocks that are joined to each other. The chaining of blocks takes place such that if one block is tampered with, the rest of the chain becomes invalid. And applying that above concept, we have the following initial block class. So let's first go down. You can see we have our inputs that we would need to actually get this going. We have the hash lib and we have time. Those are the inputs we need right now to actually start things. And you can see here we actually started filling out our initial block classes. So this is a block class here. You can see we have our method, our init method, self index, proof number, previous hash, data, and timestamp as parameters. And then you can see we have our selves. Then we have another method of calculate hash, and this is going to actually calculate our hash and give us a hash number after everything is formulated. This is actually going to return that hash lib.sha256 block of string.encode. And let's actually start reading to see what's going on with this code. So as you can see from the above code, we define the init function, which will be executed when a block class is being initiated, just like in any Python class. We provided the following parameters to the initiation function. Self-dis refers to the instance of the block class, making it possible to access the methods and attributes associated with the class. That's going to be our first one here. So that's what we're talking about here. This is the one we're talking about here when we say that part. So that's the self. This refers to the instance of the block class, making it possible to access the methods. Then we're going to have our this or index this. So the index this keeps track of the position of the block within the blockchain. That's how we're going to do that right here with this one. Then we have our proof number. This is the number produced during the creation of a new block called mining. So this is going to actually give us our number of our blockchain or our mining number when we create a new mining coin. So this is going to be our proof number here. Then we have our previous hash. Let me move down a little bit so we can see that a little bit clearer. So you can see our previous hash refers to the hash of the previous block within a chain. That's how we can do that right here. That's that one there. And down a little bit more. So we have a data this. It gives a record of all transactions completed, such as the quantity bought. And that's going to be this one here, our data this. And then we have our timestamp. Now this places a timestamp for the transaction. This actually lets us keep time of track of the time that the actual chain was created and we created it. So it makes it more easy to follow and follow along, make sure nothing's being tampered with. So after that, we move down. You can see now the second method in the class calculates the hash. We'll generate the hash of the blocks using the above values. This is how we calculate the hash here. You see block of string, and this is how we formulate it. Like I said before, these are the parameters we use. Then we have the return hash lib. This is going to return our actual blockchain. Let me move down a little bit more. So the hash 256 module is imported into the project to assist in obtaining the hashes of the blocks. After the values have been inputted into the cryptographic hash algorithm, the function will return a 256-bit string representing the contents of the block. That's what I have this right here. This is our 256-bit representing the hash of the block. Now, this is how security is achieved in a blockchain. Every block will have a hash, and that hash will rely on the previous hash block. Now, as such, if someone tries to compromise any block in the chain, the other blocks will have invalid hashes, leading to disruption of the entire blockchain. So that's letting us know that any one hash is tampered with, the entire chain becomes uh, unusable because nothing is going to be able to run if one is tampered with. So they all have to mesh together and they all have to chain together well, or nothing works together at all. So ultimately, a block will look like this. So after all of that, we have our index 2. This is our proof number 21. This is the previous hash. So this will be the blockchain right before, or this will be the block right before the one we created, the mine. And this is our sender 0, the recipient. This is who we are sending it to. And then we have a quantity of 1. Here's our timestamp here of when it was created, and that locks everything into place. Now that's just the first look at everything filled out, how we actually going to initiate getting everything going, and this is the first step of the process. Now tomorrow, or maybe not tomorrow, but later on today, we'll move into the second phase of it, of building the actual blockchain and moving on from there. But of course, I will keep you posted every step of the way. For now, it's the Python Poppy. You guys stay Gucci.